All right, so let's draw up question 2. We've got infinitely many rectangles can be inscribed in a circle. So here's the circle, and what they're saying is you can draw heaps of rectangles that have lots of different dimensions and area, right? That's one of the rectangles. You could draw a rectangle here like this. So when it says inscribed, it means each of the 4 edges touches the outside of the circle. And we've got here the center of the circle, the point of origin, and we've got the diameter of the circle is 10 centimeters. So what that means is the distance from A, B, C, D, the distance from A to C is 10, so the distance from O to C is going to be 5. All right, so we have a distance there of 5. Suppose ON is X, so they've given us ON here. That length is X. And they've said, find the area of this rectangle, A, B, C, D. Okay, so if ON is X, all right, firstly that means AB is going to be 2X. All right, so they've asked us to find the area of A, B, C, D. So that means the rectangle composed of those 4 vertices, and that's going to equal 2x, it's going to equal AB multiplied by BC. All right, AB multiplied by BC. What is AB in terms of x? 2x. What is BC in terms of x? That's a little bit more challenging. What we've got is, well, BC is equal to 2 lots of CN. All right, 2 lots of this length. And so let's abstract this triangle out and focus on that component of it. So we've got, this is 5, this is x, and we're asking about what is this side here? What can we say about the magnitude of this side? And we're going to use Pythagoras' theorem, right? A squared plus B squared is equal to C squared. We'll write that out first. And so we'll have x squared plus b squared is equal to 25, or 5 squared. And we're trying to get this component by itself. We want to know what is the size of b? What is that distance there? So we'll rearrange this and then square root both sides. So the size of this side of the triangle is the square root of 25 take x squared. It depends on the value of x. Okay, so what that means is Cn, this length here, is the square root of 25 take x squared. And so then the distance CB, or BC, is 2 lots of that. Alright, so CB or BC is equal to 2 lots of the square root of 25 take x squared. Okay, so if we just simplify that a bit, here we have 2x times 2, we have 4x square root 25 take x squared. We've got the equation of the area, right? We want to know when the area is maximized, so we're going to differentiate that. We're going to need to use the product rule, u dash v plus uv dash, in order to find the optimal solution. Draw a sign diagram to demonstrate that's where the max occurs. Okay, any questions about that one? Question 2. All right, so as we're going through them, I might make a list somewhere of the equations that we developed. So for question 2, we had the area was 4x times the square root of 25 take x squared. All right, so that's the first part of it, okay? And in the test situation, we would say, show that the area is this by making this kind of argument. All right, we'll rub out what we've done here. We'll move on to question, what did I say would be next? 3. got a 2 litre box has a square base and an open top. So we've got X as the base and Y as the height. And it doesn't have a limit. Explain why Y equals 2,000 on top of X squared. Well, we're given these units, these lengths in centimetres, right? And if we were to say the volume of this shape, it's going to be X times Y, right? Rectangular prism. The volume is equal to X times Y, which is X squared Y. And the volume is equal to 2 litres or 2,000 millilitres, 2,000 centimetres cubed. Okay, so to maintain consistency with units, we've converted the 2 litres to centimetres. And so this gives you Y is 2,000 on top of X squared. So that's the first part. Part A, explain why Y is equal to that. Part B, show that the surface area of this box. So when we think about the area of this box, okay, there's a base, isn't there? There's a bottom, and there's 4 walls. So the base is going to be X squared, and then there's 4 walls, and the area of each wall is X times by Y. Alright. Problem here is we've got 2 variables. Fortunately, we've expressed Y in terms of X, so we can perform that substitution. And then we'll just simplify it. Okay, so for equation 3, X squared plus 8,000 on X. Alright, so we've shown that that's what the equation is. Very good. So question 4 we'll definitely have a go at. Let's talk about question 5. So we have the function e to the minus x squared. Bell curve. And we've got in there a rectangle. A, B, C, D. And the function is e to the minus x squared. Determine the coordinates of C, determine the coordinates of this point, such that the rectangle has maximum area. Okay, so what we're going to do is we're going to define this length here as x. Okay, from O to D, that's x. And so this length here is also x. Alright, I'm not saying what's the coordinate here, I'm saying what's the length of that. If this length is x, then this length is going to be x. So that means AD, this length along AD, is, that whole distance there is 2x, right? Now, if this is x, how tall is it? Alright? Now if you think, if this was 2, if x was 2 or 3 or 4, and I said how high is it here, you'd say, well, let's take that x value and put it into this function, right? We'd take the number 2 and put it in here, or we'd take the number 3 and put it in here. We've got an x value of x, which means the height, the y value, is this. The highest that goes off the x-axis is e to the minus x squared. And so the distance CD is equal to e to the minus x squared. Whatever the x value is, the height of it depends on x. And so then the area is 2x e to the minus x squared. Okay? AD times DC. Alright, there we need to use the product rule again. So that's 2, 3, 5. Okay, so question 4 and question 7, you were given the equations there, so you can definitely have a go at them. Now, I just want to caution you with questions 6, 8 and 9. The reason I haven't written these up here is because they use what's called double angle formula. And I've spoken to a number of you about these already. Those are from the specialist maths course. You're not required to know the double angle formula, so you wouldn't be required to arrive at one of those equations. Nonetheless, once you've got the equation, you could get it from the answers, you can still use the equation to arrive at the optimal solution. Okay? So just be wary of those 3 in particular. I'm not going to ask anything involving double angle formula. All right, and it's not in your exam either. It's not part of our course. So we've got question 5, and we had the formula was 2x e to the minus x squared. Okay. All right, any questions so far? So we've got most of the equations out here. Let's have a go at question 10, and then question 11 is going to be pretty similar to 10. So let's show you how we get the equation for 10. I'll draw it up. We've got A, B, N, X, and we've got 1 and 2. All right, let's read it. A pump house is to be placed at some point along a river, and 2 pipelines will connect the pump house to homestead A and homestead B. So there's a body of water here, and we want to pump water from the river, somewhere along the river, to both house A and B. The question is, where should X be? How far should point X be from M, such that the amount of pipe, we're using pipe here and we're using pipe here, such that the amount of pipe is minimized. Okay, so, and this distance up here that they're apart is 5. All right, so if we define this length as X, okay, X being from M to capital X, all right, we're interested in an equation, so the total distance of the pipe is equal to length AX plus length XB. Right, length AX plus XB, that's where we've got pipe going. All right, here's the water. We're going to pump water to the house at A and the house at B. And if we think of AX, how far is this? We can abstract that triangle, right? It's a right angled triangle. Here's what it would look like. We've got 2, we've got X, and we've got, this is AX. This is what we're trying to find. And so what we'd have is 2 squared plus X squared equals AX squared. And so that'll be 4. And so AX is the square root of 4 plus X squared. All right, now I have seen people go, therefore AX is 2 plus X. That is not true. Okay, you can only square root if they're a product. They're not multiplying one another, they're a sum. And so the simplest we can leave it is as it is expressed above. So this distance here, AX, is the square root of 4 plus X squared. And then we need the distance XB. So we're talking from here to here. Well, we know this is 1, and so we need to have some expression for xn. This total distance is 5. This distance is x. Therefore, this is 5 take x. Xn is 5 take x. So then if we just focus on that triangle, we're going to have the same thing. I like to pull the triangles out of the shape. So we've got xb, 1 and 5 take x. And pulling them out of the shape helps you just break it down into, that's a simple pi thing, right? We've got 5 take x squared plus 1 squared is equal to xb squared. And look, at that stage, you can expand that if you want to, but we don't need to. We don't need to keep it. So we've got xb, all right, and so then we're going to just chuck that back up here for the distance equation. The square root of 5 take x squared plus 1 squared. All right, so the formula that we're using then, all of that was to arrive here. That's the formula for the distance of the pipes. So yeah, that's going to help you find how far apart they be, where should we put M, how far from M should we put it. That's going to be our goal index. So there's some pretty tricky problems, hey? But like I've said, developing the equation is going to be worth a couple of marks, 2 or 3 marks. So yep, it's a skill we want to be able to do. But I think the most important part is this part here, finding the optimal solution. All right. Optimal solution occurs when the derivative is 0, make the function differentiate, make it equal to 0, and evaluate it. Okay. So I'd like you to have a bit of a wrestle with them now that I've generated some equations for you, now that I've shown you how we can find some of the equations. Hopefully that's not something that's getting in the way of this exercise. So, challenging? Let's give it a go.
It's extreme pain.
Why is that?